During the Second World War, battles were fought not only on land and in the air, but also deep beneath the ocean's surface. These silent ocean predators, submarines, became the fearsome wolves of the seas, invisible hunters that could strike unexpectedly and vanish again into the darkness of the depths. Their role was strategically decisive. German U-boats strangled Allied sea supply in the Atlantic. American submarines sank Japanese ships in the Pacific, while British and Soviet submarine flotillas faced the enemy in their own waters. When people speak of the Second World War, many imagine tank battles and fighter races. In the shadow of those glorious clashes, however, there was also an invisible war underwater. And behind every submarine that took part in it stood enormous industrial and human effort. To build a submarine meant procuring thousands of tons of quality steel and other materials, manufacturing countless parts, from periscopes to engines, and employing hundreds of engineers and workers for many months of intense labor. Submarines were the technological marvels of their time. Incredibly complex machines, practically underwater fortresses packed with engines, torpedoes, electrical systems, and the most advanced equipment of the day. In this video, you will learn how submarines were actually produced during the Second World War. Together, we'll look into the secrets of the shipyards and submarine factories, from the first drawings on drafting boards, through the hiss of welding rods on the steel hull, to the dramatic launch of the finished vessel. We will uncover how different nations approached submarine design and construction. You will see how the methods of Nazi Germany, the United States, and, for example, Japan, differed. We are in for gripping stories, such as how Americans managed to build modern submarines hundreds of kilometers from the ocean, or how the Germans, toward the end of the war, tried to assemble submarines in sections inside secret hangars hidden from air raids. In a moment, we will open the first chapter of this story, what the birth of a steel underwater predator involved from the very start. Before riveting hammers and welding torches rang out in the shipyards, the submarine was first born on paper. Naval designers had to create a vessel strong enough to withstand the tremendous pressure of deep water and at the same time, powerful and well-armed enough for combat. To convey the complexity of a submarine, everything that had to be made and installed, there were the hull and diving systems, the strong inner pressure cylinder, and the outer hydrodynamic casing. In all, hundreds of tons of steel. Then ballast tanks, valves, and pumps to control buoyancy. The power plant, large diesel engines for surface running, electric motors, and thousands of kilograms of batteries for submerged running. Shafts and propellers. Weapons, torpedo tubes, often 4 to 6 in the bow and 2 to 4 in the stern. Dozens of torpedoes, sometimes a deck gun and anti-aircraft guns. Sensors and communications, primary and spare periscopes, hydrophones, the submarine's ears for passive sonar, radar and radios, gyrocompasses, and hundreds of instruments. Life support systems, ventilation and oxygen generation, CO2 filters, food stores, and water for a crew of 20-70 people, depending on the submarine's size, for long weeks beneath the surface. Submarine construction involved not just the shipyard itself. Hundreds of other enterprises supplied components, from propellers and valves to complex instruments. Optical systems for periscopes, for example, were made by firms such as Carl Zeiss. Diesel engines were supplied by MAN for German submarines, or General Motors for American submarines, and massive electric batteries came from specialized chemical plants. Each submarine was thus a construction set of parts from across the country, brought together only at the yard. Once the plans were ready, construction could begin. The process resembled shipbuilding, but had its own specifics. The backbone of a submarine was the so-called pressure hull, a strong steel cylinder in which the crew lived, and which had to withstand the crushing pressure of surrounding water at depth and possible underwater explosions. Most wartime submarines even had a double hull, the inner pressure hull surrounded by a second outer hull, which had a streamlined form and, in the interspace, carried the ballast tanks. Construction usually began with laying down the center section, the submarine's notional keel, on the building ways. Around this framework, steel plates forming the hull were gradually fastened. During the First World War, these plates were riveted, but by the late 1930s, most countries had switched to welding. A welded hull was stronger and sealed better, allowing safer dives to greater depths. Every seam had to be perfect. Even a small leak when diving could spell danger for ship and crew. Work at the yard went on day and night. Teams of fitters, welders, electricians, sandblasters, and other specialists gradually turned abstract drawings into a real submarine. When the steel jigsaw of the hull was complete, interior outfitting began. Building a submarine was like assembling a giant three-dimensional puzzle. It had to be planned precisely in what order to fit engines, generators, battery elements, kilometers of cabling, piping, pumps, instruments, and other equipment into the narrow cylindrical hull. Many components barely squeezed through the hatches. For example, large diesel engines or electric generators were often installed before the final sections were closed, because later they simply would not fit into the completed submarine. Every part had to be in its place, from the torpedo tubes in the bow to the rudders and propellers aft. When all vital equipment was installed, the hull was closed up and the submarine received its characteristic shape, including the sail, conning tower with periscopes, and the command post. At last came the ceremonial moment, the launch. The finished submarine stood on supports on a slipway leading to the sea or a river. This moment was both risky and spectacular. At traditional yards, smaller submarines were launched like ships, stern first or on the keel, sliding into the water along a greased way. Elsewhere, where space was tight, launching took place sideways. The vessel slid off on its beam and with a thunderous splash, rocked on the surface for the first time. Every designer and captain caught their breath at that first contact with the water. The submarine had to sit right, not capsize, and above all, not leak. Yet even after a successful launch, victory was far off. Days and weeks of final work at the outfitting pier followed, installing remaining equipment, calibrating electronics, testing engines. Only after that did the submarine go on its first trials. During sea trials, the crew, under the eyes of technicians, had to test all systems, including the first deep dive. If problems were found, the submarine returned to the docks for corrections. Once everything functioned and the boat passed all tests, it was time to hand it over to the fleet for combat service. The new submarine was ceremonially christened and officially commissioned. Even before that, as a rule, her crew had already been formed. The future captain and selected sailors came aboard during the final construction phases and took part in trials together with the technicians. Thanks to this, they bonded with their submarine from the first moments and were well prepared when the time came for combat deployment. Such was the general process by which a wartime submarine was born. Each country, however, adapted it to its capabilities and needs. Different materials and technologies were available at American shipyards. Very different conditions reigned at besieged factories in Germany or the Soviet Union. In a moment, we will look into the Third Reich, how Germany launched giant U-boat factories, and what innovations and desperate measures it resorted to. In the early 1930s, Germany was prohibited from building submarines under the strict terms of the Treaty of Versailles. Naval officers and engineers, however, quietly gathered experience abroad. And as soon as the Nazis renounced the ban in 1935, German shipyards resumed submarine production. The backbone of the German U-boat fleet became the robust Type 7 boats. They were relatively small, but highly efficient and amenable to series production. On the eve of war, however, Germany had only about 50 combat-ready submarines. The U-boat arms commander, Karl Dönitz, declared then that to truly blockade Britain effectively, he would need at least 300 submarines at sea at the same time. Germany strove toward that number during the war, and indeed launched an unprecedented armaments program with few parallels in history. After a slow start in 1939, when only a few new U-boats were completed, output rose sharply. By 1941, dozens were being finished each year, and production peaked in 1944, when German yards produced nearly 400 submarines in a single year. In total, from 1939 to 1945, the Germans built more than 1,100 submarines of various types. Their submarine fleet, the famous Grey Wolves of the Atlantic, was thus continually replenished, despite severe combat losses. Such mass production demanded an enormous strain on German industry. Yards in Hamburg, Kiel, Bremen, and even occupied Gdansk worked at full capacity. In 1943, Albert Speer took over armaments management and introduced strict centralization and standardization. Submarines began to be assembled from prefabricated sections. For example, steel sections of the hull were manufactured by steel and engineering plants in the interior, and then transported by rail or water to the final assembly docks. This approach not only shortened construction time, it also hid part of the production from Allied air raids. From 1943, British and American aviation systematically bombed submarine pens and shipyards. The Germans therefore invested in enormous reinforced concrete shelters and bunkers in which they hoped to build submarines under meter-thick ceilings. The most famous of these was the Valentin bunker near Bremen, a 400-meter concrete hall intended to house a submarine assembly line. The bunker was partially completed using forced labor by prisoners, but Allied bombs heavily damaged it before it was finished, and not a single submarine rolled out of it before the war ended. A night at the turn of 1944 at a North German shipyard. In a vast assembly hall, lit by only a few lamps, a young welder, Hans, kneels by a massive steel cylinder section of a hull. He brushes off the sparks that flew when he finished another seam on the submarine under construction. The air smells of smoke and heat. Hans knows it's freezing outside, but inside the hall, the welding glow blasts warmth and his hands are sweating. Suddenly, a rumble, distant bomb blasts as British aircraft pound the port again. The hall shivers slightly. Hans pauses for a moment and looks up. Dust trickles from the ceiling beams. He wastes no time, strikes the arc again, and keeps welding. This submarine has to be finished, the exhausted worker repeats to himself. We must launch her so she can defend our land. In the quest for a decisive advantage at sea, the Germans also turned to technological innovation. In 1943, they began developing the revolutionary Type 25, nicknamed the Electroboot. For its time, it was an incredibly advanced machine, a submarine built for prolonged submerged operation, equipped with powerful batteries and a retractable air induction snorkel, capable of higher speed underwater than on the surface, and almost able to match fast escort vessels. Rather than build a prototype, they plunged straight into series production. Its production was to resemble an assembly line. Hulls were assembled from pre-made sections supplied by various factories. German propaganda promised that this wonder weapon would turn the tide of war. But the shift to the new process brought huge difficulties. Sections from different factories often fit poorly and required complex adjustments on site. There was a shortage of skilled labor. Many experienced shipyard workers had gone to the front. In the plants, they were replaced by inexperienced trainees, older men, and workers from the ranks of totally mobilized foreigners. These people were usually compelled to work under hard conditions, which affected morale and workmanship. Surviving reports indicate that sabotage also occurred in the desperate atmosphere of the war's end. At one firm producing electrical systems for submarines, workers allegedly damaged cable insulation on purpose so new U-boats would suffer faults. Allied bombing, moreover, continued to disrupt transport of sections and material deliveries. Even so, by spring 1945, about 120 Type 25 submarines had been completed, an impressive number, but far too late to alter the outcome. Of these, only 2 were fully introduced into service, and only one, U-2511, sailed a combat patrol shortly before capitulation. While the Type WWII represented the pinnacle of German engineering, the Germans simultaneously bet on the opposite extreme: small, cheap one- or two-man submarines. As the situation at the front worsened, so-called midget submarines for coastal operations appeared. These small craft, like the Biber, Molch, or two-man Seehund, could be produced quickly and under improvised conditions. Often they were more like oversized torpedoes with a man inside. About 250 two-man Seehunds were assembled by war's end and deployed in the English Channel and off Europe's coasts in the winter of 1944-45. Their task was to creep up on ports and sea lanes and attack Allied ships with torpedoes. Midget subs, however, suffered technical problems, and their inexperienced young crews often died in accidents or combat. A few small successes, such as sinking a pair of merchantmen with Seehunds, could no longer affect the war's overall course. These projects, however, showed the desperate experiments Germany was willing to invest in at the end, from ultra-modern colossi to disposable craft for a last stand. Germany's gigantic U-boat enterprise ultimately collapsed. The factories turned out impressive numbers of boats, and German engineers pushed submarine development forward by miles. But the Allies deployed effective anti-submarine weapons and defenses. Losses were so high that even feverish construction could not replace experienced crews or keep pace with the rate of sunken boats. Germany capitulated before the new submarines could prove themselves. In a moment, we will see how, at the same time, the Allies, specifically the United States, managed to build their own submarine factory that rivaled even German efforts in productivity. The United States also developed modern submarines intensively before the war, though they were not yet fighting until December 1941. The U.S. Navy entered the war with several dozen submarines, but it soon became clear that far more would be needed for large-scale operations in the Pacific. Under the banner of the Arsenal of Democracy, the U.S. launched an unprecedented tempo of war production, and submarines were no exception. The challenge was expanding capacity. The traditional supplier, Electric Boat in Connecticut, could not meet demand alone. The Navy therefore mobilized its own yards, such as Portsmouth Navy Yard in New Hampshire and Mare Island in California, and even turned to plants that had never built submarines before. Thus, the smaller Manitowoc Shipbuilding Company, located deep inland on the Great Lakes in Wisconsin, also took up production. Manitowoc's story shows the determination and ingenuity of American industry. In 1941, the yard received a contract for 10 Gato-class submarines, even though local engineers had seen submarines only in pictures. Electric Boat provided plans and know-how, and Manitowoc began feverish preparations. First, local craftsmen built a full-scale wooden mock-up of a submarine, an exact replica including corridors, compartments, and equipment dummies. New workers could feel what a submarine looked like inside and practice installation procedures in the dry. From a small regional plant, a giant grew. From the initial 500 employees, it expanded to 8,000 working in 3 shifts. Women joined the workforce, unprecedented there before. About 600 women completed welding or metalworking courses and soon stood side by side with men at the machines. Across the U.S., hundreds of thousands of women entered war plants. Rosie the Riveter, symbols of the home front. At Manitowoc, women made up under 10% of the staff, yet significantly helped cover labor shortages. American Gato-class and later improved Belau-class submarines were larger than their German counterparts, about 95 meters long, displacing around 1,500 tons surfaced and up to 2,400 tons submerged, nearly twice the usual Type 7 U-boat. The complexity of their design and construction matched that size. Americans, however, applied modern industrial methods to speed serial production. All the yards used shop floor prefabrication of submarine parts. The hull was divided into several large sections assembled in parallel under roof, protected from weather. At Manitowoc, for example, the boat was divided into 16 sections, plus a separate conning tower. Each section, weighing tens of tons, was fully outfitted in the shop with piping, cabling, and bulkheads. Only then did a special traveling crane bring it to the ways to join with the others. To do this, Manitowoc had to build its own equipment, from conveyors to a 60-ton portal crane. They even developed a clever rotating welding frame, an enormous metal fixture that gripped a hull section and allowed it to be turned so the welder could always work in the optimal overhead to downhand position, minimizing defective seams. Each joint was strictly inspected. Quality was paramount for the Americans, since their submarines had to endure deep dives and tropical ocean crossings. June 1944, Portsmouth Navy Yard. Naval officers and their families stand on a wooden grandstand. Below at the pier, 4 gleaming Below-class submarines sit side by side. The moment has come. All 4 will be launched simultaneously. It's a sunny day, and the American flag flutters above the yard. Workers in coveralls mingle with sailors in uniform. No one wants to miss the spectacle. A ship's siren sounds. The wooden blocks holding the submarines on the ways are knocked free. One after another, the steel vessels begin to move. To the music of a brass band and cheers from the crowd, the first submarine slides into the water, then the second. Within minutes, all 4 giants are afloat. Spectators erupt in exultant shouts. This is a celebration of industrial triumph. In the single year 1944, the yard built 32 submarines, an unprecedented feat. The result of these innovations was huge productivity. Whereas early war boats took many months to finish, by the end of the war, average build time had dropped to only a few months. In January 1944, Portsmouth set a record by ceremonially launching 4 new submarines in a single day. That year, Portsmouth completed a total of 32 submarines, more than any other yard in a year. During the war, American plants built more than 200 submarines, 77 Gatto-class, about 120 Below-class, and several other types. Manitowoc, for example, delivered 28 submarines in just under 3 years, 25 of which saw active combat. Each completed submarine immediately faced a long journey to the theater of war. Boats from Manitowoc had to cover thousands of kilometers just to reach the ocean. After trials on Lake Michigan, they moved via canals and rivers. There was no direct navigable path to the Atlantic, so engineers boldly resorted to a floating dry dock. The entire submarine was submerged into an enormous pontoon, which tugboats hauled down the Mississippi. To fit under bridges in Chicago, periscopes and radar masts had to be temporarily removed, then remounted after arrival at the river's mouth. The journey ended at a Gulf Coast yard, Gulfport in the Gulf of Mexico, where submarines received final tweaks before sailing to Panama and onward to the Pacific. American submarine production succeeded not only in quantity, but in quality. U.S. submarines proved highly effective in combat, reliable with long range and good equipment. When the Japanese fleet suffered devastating losses of supply ships, American-made submarines contributed significantly. One could say the Americans created beneath the surface their own arsenal of democracy, a flotilla that helped tip the balance. While new submarines celebrated successes in Pacific docks, other allies in Europe continued their own submarine production. It is less well known that Britain also built submarines in large numbers, and the Soviet Union managed to preserve a substantial flotilla. In a moment, we'll look at how submarines were built in the island kingdom under the threat of German raids, and its Soviet plants evacuated far to the east. Britain entered the war with a flotilla of 57 submarines, and soon realized they needed to be modernized and expanded. British submarines deployed mainly in the North Sea, the Atlantic, and the Mediterranean, where they faced Axis fleets. British shipyards had a long tradition, having built submarines since the First World War, and could therefore increase output relatively quickly. Key production centers included Vickers in Barrow-in-Furness and the government dockyards in Portsmouth and on the River Clyde in Scotland. Although Allied bombers devastated German factories, The British also had to withstand German raids on ports and industry. Even so, production did not stop. During the war, Britain introduced several new submarine classes and built about 170 submarines in total. Among the most numerous was the U-class, smaller, simpler boats initially meant for training, but used in combat off British shores and in the Mediterranean. For long-range patrols, the British developed the more powerful T-class, which operated even in the Pacific. British submarines differed in design from German or American types, often double-hulled and suited to longer time on the surface, with deck guns for surface action. British yards worked under pressure, having simultaneously to build numerous escorts, destroyers, and corvettes to fight U-boats, so capacity was stretched. Women helped in production, as in the U.S. The tradition of ship christenings was not abandoned even in wartime. New submarines were ceremonially named before launch by breaking a bottle of champagne on the bow in the presence of a ship's sponsor. Many naval officers were superstitious and believed that if the bottle didn't break, the ship was doomed. Fortunately, most British submarines passed their christenings without mishap and could head to war, where they, for example, significantly contributed to weakening the Italian fleet in the Mediterranean. The British also built a few special midget submarines called X-craft. In September 1943, these tiny four-man submarines penetrated Norway's Altafjord and, using explosive charges, seriously damaged the German battleship Tirpitz. Even such daring uses of submarine technology found their place in the war. The Soviet Union also built a submarine flotilla, despite terrible losses in the war's early years. At the start of the conflict, the Red Fleet actually had the largest number of submarines in the world, more than 200, but many were obsolete, and in the chaos of 1941, dozens fell victim to the German advance and minefields. Factories in the western USSR had to be evacuated before the oncoming enemy. Part of production was moved far east to regions on the Volga, in the Urals, and in Siberia, beyond the reach of German bombs. Even under improvised conditions, however, completion of submarines for the Soviet fleet continued. The Soviets focused mainly on smaller submarines suited to operations in the shallow seas off their coasts, such as the Malyutka M class, about 45 meters long, fast, and maneuverable in the Baltic and Black Seas. For the Pacific and far north, they built larger ocean-going submarines of the Shchuka, Shchuka, or K classes. Production often took place in harsh conditions. Workers labored in freezing weather with shortages of materials and machine tools. Nevertheless, patriotic effort enabled completion of a respectable number of submarines, an estimated 200 during the war years. In besieged Leningrad in 1942, for example, shipyard workers, despite hunger and shelling, managed to assemble and launch several submarines. Such stories illustrate the incredible resilience and sacrifice of those who built submarines. Soviet submarines ultimately played a significant role, especially late in the war. In the Baltic, they torpedoed evacuating German ships, and in the Pacific, they joined the August 1945 offensive against Japan. As we see, not only the major Axis powers invested in submarine construction. Even economically strained Britain and war-ravaged Soviet Union managed to sustain and renew their submarine forces. Submarines patrolled Arctic convoy routes, the Mediterranean, and Far Eastern waters, and contributed to the enemy's final defeat. Now we need to look at the conflict's last side, the Japanese Empire and its submarine program, which in many ways pushed to extremes. In a moment, we will reveal how the Japanese and their allies built submarines and why their efforts ultimately proved insufficient. In the Far East, the third great Axis power, Imperial Japan, went to war with no less ambitious aims beneath the surface. The Imperial Japanese Navy had maintained submarine forces since the First World War and emphasized quality and innovation. During the Second World War, the Japanese built several unique designs with no parallels elsewhere. For example, the I-400 Sentoku class were the largest submarines of their time, over 120 meters long, with a hangar on deck for 3 folding floatplane bombers. These were essentially submarine aircraft carriers, intended for surprise attacks on distant targets. Plans included bombing the Panama Canal or the American coast. The project, however, came late. Of the 18 planned, only 3 were completed by the summer of 1945. Another development direction was extremely fast submarines for defending the Japanese home islands, the I-201 class. These smaller, streamlined boats reached submerged speeds of about 19 knots, among the fastest in the world, allowing them to outrun typical American escort ships underwater. But only a handful were produced, and they had minimal impact in combat. Japan, however, lacked the capacity to produce submarines in numbers comparable to the US or Germany. In all, it built about 65 ocean-going submarines during the war, many in the early years, plus several dozen midget submarines, and, late in the war, hundreds of kite and suicide torpedoes, an estimated 300 plus. The 2-man Ko-Hyoteki midget submarines became notorious for the failed attack on Pearl Harbor in December 1941. 5 were sent to infiltrate the harbor, but none reached its target. The wrecks of some were discovered on the harbor bottom only decades later. Even so, production of these craft continued, and they were used in defending islands and ports. Over 50 were built. By war's end, as hope faded, Japanese command embraced the chiton concept, literally heaven shaker. A chiton was a modified long torpedo with a small cockpit for a volunteer suicide pilot who would guide the warhead to a target, typically an American warship, and detonate on impact, dying with it. Chitons were hastily assembled in coastal workshops and deployed from the decks of large submarines or coastal bases. A few times they did hit American ships, damaging, for example, the tanker USS Mississiniwa in November 1944. But most missions failed and ended with the crew's deaths to no effect. Japanese submarine industry, like Germany's, faced ever tougher conditions. From 1944, yards suffered material shortages, quality metal, fuel, and electricity were lacking. American raids devastated ports like Kure, Sasebo, and other production centers. Japan could not protect its yards from bombing as the Germans tried with bunkers, and production faltered. Many submarines remained unfinished or could not put to sea for lack of trained crews. In a desperate attempt to bolster the war effort, the Japanese even tried technology exchanges with Germany. Several secret voyages by German and Italian submarines to Japanese ports, the Yanagi missions, took place, carrying optical instruments, weapon plans, or strategic raw materials such as ores and rubber. Only scraps of such cargoes arrived successfully. Most submarines on these routes were sunk by Allied forces, underscoring the Axis powers' hopeless situation. Of Europe's Axis allies, only Italy played a further role in the submarine war. It began the conflict with an impressive flotilla of more than 100 submarines, the third largest in the world. Italian boats operated mainly in the Mediterranean and the Atlantic. Although Italian industry also built new submarines, it could not match German or American tempo. About 20 new boats entered service before Italy capitulated in 1943. The Italians, however, became famous for another mode of combat. The Decima-mass naval commandos developed so-called manned torpedoes, maiali. These were essentially miniature 2-man torpedo submarines on which pairs of daring divers infiltrated enemy harbors and attached mines to ship hulls. These riders sank or damaged several British ships, for example, disabling 2 British battleships at Alexandria in 1941. Some Italian submarines also achieved notable success. The Leonardo da Vinci sank 17 Allied ships, ranking among the most successful Axis submarines. Italian midget sub-technology scored in such special operations, but could not, of course, replace classical submarine forces strategically. After Italy's capitulation, some of its remaining submarines were taken over by the Germans and incorporated into the Kriegsmarine. Others were scuttled by their crews. At the war's end, Axis submariners had to accept defeat. From their last bases, Only isolated submarines sailed on suicidal missions, while enemy fleets dominated sea and sky. When Japan capitulated in August 1945, some of the world's most advanced submarines fell into Allied hands, the German-type WWII and the giant Japanese I-400s. These trophies were studied in detail before their final fate was sealed on the seabed. Yet the story of submarine production does not end there. Designers still draw on wartime experience today. In total, during the years 1939–1945, the warring countries produced roughly 2,500 submarines of many types. The largest number came from Nazi Germany, over 100. Next were the United States, nearly 300. Britain built more than 170 submarines, the Soviet Union about 190. Japan completed more than 60 large submarines, plus dozens of midgets. Such mass production of undersea vessels had no parallel in history. The Second World War ended, but the legacy of the vast efforts devoted to submarine construction remained. The technologies, processes, and experience gained in 1939–1945 became the foundation for post-war submarine development. For example, the design of the German-type WWII served as a template for the Victor's post-war submarines. The Soviets developed their Whiskey class on its basis. Americans and Britons tested captured examples, transferring many innovations, from hull form to battery layout, into their own boats. The Electric Boat Yard, which had produced diesel-electric submarines during the war, built the first nuclear submarine, USS Nautilus, only a few years later, drawing on rich wartime production experience and new technologies. The practice of prefabricating large sections found application in shipyards worldwide. Even today, modern submarines are built in parts, modular construction, and only joined together at the end, just as engineers in Portsmouth or Manitowoc pioneered in their time. The wartime submarine boom also taught much about organizing labor and mobilizing society. Stories like Manitowoc's enthusiasm or the heroism of workers laboring under fire show what great things can be accomplished together. At the same time, they remind us of the dark side of industrial war, its suffering. Submarine crews bore extreme risk. The German U-boot Waffe lost 3/4 of its men, the U.S. Navy lost 52 submarines with their crews, and the British submarine service wrote off 79 boats. To be a submariner was to live the war in a cramped and dangerous world, where every dive was a matter of life. Today's submarines are incomparably more advanced than their Second World War ancestors. They are powered by nuclear reactors, can cruise unseen for months, and carry weapons capable of destroying entire cities. Cutting-edge science goes into their construction. Design is digital, and sections of the hull are often welded by automated robots at a handful of highly specialized shipyards in the world. Since 1945, there has never again been submarine production on the massive scale of the Second World War. Although hundreds more submarines were built during the Cold War, production stretched over decades, and the focus shifted from quantity to quality and technological sophistication. Even so, these modern steel colossi would never have arisen without the path, full of trial and error, enthusiasm and suffering, that humanity traveled in the first half of the 20th century. When you visit a museum today and step into the cramped innards of a veteran Second World War submarine, you're surrounded by cold metal and the smell of old oil, and perhaps you'll remember all those unseen heroes in coveralls who long ago built that steel ship step by step. Thank you for diving into this story to the end. If you enjoyed the video, please leave a like and share it so others can learn about the fascinating history of submarines. I'll be glad to hear your remarks and comments. See you next time. M.